So Valentina and Kuning and Marcus again. So let's check if the speakers are here. I'll remove the sharing, otherwise I cannot see you. Okay, so let me be back. Yes.
Hello, everyone.
Hello. Hi, nice to see you.
Nice to see you.
The first speaker is here. Let's check for the other speakers. 1 minute before we start.
Hello.
Okay, perfect. Hello, hi. So you're going to present the second paper, right?
Yes.
Okay. And I saw before Marcus connected, so I guess he's here as well. Let me check. Marcus, just to make a test that everything is working fine. If you can activate your camera so we can see you and we can be sure that you are also here. Okay, not yet, maybe. So let's start meanwhile. Let me give the space to you, Valentina, to present the first paper of the first conference of kind. So it's I think it's a big pleasure. So, and let me leave you space, please.
Thank you very much.
I'll give you a sign when a couple of minutes are left, okay?
Okay.
So try not to interrupt, but at least to be informative.
Okay. I'll try to share my screen now and hope you see the slides now. Okay,
Perfect.
so it's a really nice experience and a great pleasure to present and to open the conference. And what I'm going to present today is our paper done together with Valentina Lenarduzzi from the University of Oulu and Michael Felderer, University of Innsbruck. We conduct a study on what is the software quality for AI engineers and towards seeing of the fog. As we all know, quality for AI is not yet explored as maybe some other things. We are all here together because there is an increasing role of AI systems in the world, and AI-based components are being implemented more and more. Even there are some projects where AI is the core component, but together with that, we already know that there are some crucial differences between traditional software and AI-based software. There is a different structure of the code, there is a different modularity system, and probabilistic nature of AI software also doesn't allow to apply traditional testing approaches as for the traditional software, and also training. The developers of AI software sometimes are not even engineers or don't have the traditional computer science or software engineer training, which can influence then the quality of the code. And that's why we probably need a new systematic software quality assurance approach for AI-based systems. And for our study, we decided to figure out and explore, first, to identify the quality issues developers experience in the AI-enabled while developing them, and second, describe the quality practices that are already available and which quality practices are missing. For these reasons, we conducted the interviews with experts. They all had to do with the development of AI components, and their companies where they worked had AI either as a core component or one of the main components of the company. The experts came from the different domains, from fintech, from natural language processing, video, some visual areas, and so on. And they also had all different roles in their companies, from the data science leaders to SEOs and CEOs of the companies. Process you can see on this slide, but we also uploaded all the raw data of the interviews online, so you can find the link in the paper and also have a look yourself how the different experts answered the questions, and also have a look at the questions and at the survey. Now let's come to the results. And those are the most reported issues that we have. First of all, of course, people mentioned the data handling and model training are the most challenging things. And as one of the participants stated, this is basically the description of his job, just to do the data handling and the model training. But it's not the only issue that they mentioned. And then the second one was the invisible errors leading to the worst performance. Those are some changes in a model parameters, or maybe some changes in the libraries packages they use that at first are not recognized as bugs. There are no bugs, right? But they lead to the worst performance, and they are not very difficult to detect with the tools that are available right now. Then the clearance of the code, probably connected with the different training of graduates. But the experts mentioned that the clearer code, the better modularity, reuse of the existing code, it might be a problem. Scalability and compatibility. The more the project gets, of course, the more problems with scalability arise. The same comes to compatibility. Projects have to be compatible with all the different devices, especially in area of Internet of Things. Also a big problem. Framework stability and reproducibility of results. Also, with the current tools, it might be sometimes very difficult to ensure the stability of the infrastructure and stability of the development process. Different training of graduates, since some of them have a computer science background, others have data science and more economics background, and this all, of course, influences or has the influence on the final quality, and miscommunication, especially between the software engineers and data scientists, since different terms are being related to different issues and different for instance, testing and AI engineering is not the same as testing in software engineering, and that might be a problem. Then we asked them which quality practices they already use to ensure the quality of AI components, and this you can see on the left side. We asked it in very detail for them to describe everything that they use. And then to compare, we asked them also what do they use to ensure the quality of the whole system, and this you can see on the right side. And what's interesting here, so we can see, of course, all the traditional and interesting approaches that people apply to ensure the quality, but there are some things that are applied to the traditional or to the overall system that are not applied to the AI components. And those are control, static code analysis, and coding standards. As for coding standards, it might be some coding manuals or ISO standards and so on. They are used for the overall system, but not used for the AI components. Static code analysis as well. There are tools, even a lot of tools for the traditional software, but not as many tools for the AI-based components. And version control. So our findings, of course, data and model quality are the main issues. And it was already, so we just confirmed this and everyone knew this already, but those are not the only issues. And those are not the only things we have to keep our focus on. Of course, is the main software quality assurance technique. But new testing strategies are required, since current testing sometimes doesn't cover everything and doesn't give us, new monitoring techniques are also required. Low adoption of software quality standards might be connected first with they just don't exist, first of all, like software quality assurance standards for AI components. And secondly, they are so abstract mostly, and traditional software quality assurance standards are often unsuitable. So there are not, so from our experience, so from what we found, there was not a wide usage of SQA standards. Code quality might be related to the background of the respondents, but more study in this direction is needed. And what's also very interesting, that already small and medium companies, and probably I forgot to mention it, but all of our respondents came from the small and medium enterprises. Even they already don't rely on external libraries, since because of the security reasons, because of the stability reasons, already they first have to research and confirm that the library is safe, and only then they use it. Or often they just write the libraries themselves, especially if it comes to the security issues. So what can be done from what we discovered? What can be done in the future? So first of all, what we have to focus on, I know that in the European Union, they already focus on it, and there is a lot of research on the topic, is the new quality standards for AI development. Then version control for AI projects is needed. The current version control systems are not suitable or do not provide all the whole monitoring or the tracking of the issues that we have. If we have version control for AI, it might prevent a lot of these subtle issues that we are not we cannot notice when we change something, but that in the end come to the worst experience. So version control would be a very important topic in the future, or already now. Then university quality measurements for external libraries would be an interesting topic to research on. That would increase the trust of the industry to the external libraries, or also help the small companies to navigate between all the different packages and all the different libraries existing out there. And the relation between the quality of the code and the background of the developers is an important issue, I would say, since it would influence the preparation program of people with different backgrounds, and preparation of future specialists is, of course, of great importance for the quality of the overall AI community in the future, and so on. So that's it from my side. I tried to keep it as short as possible, and now you can ask any questions, and if you want to ask something. Thank you.
Thank you very much, Valentina. So first of all, let's make applause. I mean, we lost this usage when we got with the virtual, but I think it's very important. So we already have a couple of questions. And Jane, do you want to make it voice? I think it's better if we can just repeat the question. Thank you.
Sure. Yeah, that was an interesting talk. Thank you very much, Valentina. I was just curious about something on one of your really early slides when you mentioned that the second kind of most important problem that they identified was about the performance, invisible errors leading to worse performance. Did they explain anything about what they meant by performance? Because obviously people perceive it in a different way. I'm assuming it's not just about speed and things, there's qualities involved as well.
Yeah, thank you for the question, Jane. So the performance, what they meant, of course, for different companies is a different thing, but I think it's F1 score, it's the precision, it's the accuracy, and so on. So of course, for different projects, different variables or different measurements are important, but they're talking about the precision or the accuracy of the model.
Okay. Did they talk about fairness and things like that at all? That was kind of interesting.
Yeah, so because it wasn't the main topic of our research, we didn't ask about it in detail. But okay. Of course, so in industry they also really consider the fairness and they pay attention to it.
Okay, great. Thank you very much.
Thank you. So there is also another question from Andre. So I assume that you can take the microphone and make your question as well.
I could try. Can you hear me?
Okay. Yes. Perfect.
Yeah. Okay. Thank you. That was a great way to start the conference, I felt. Not the conference, but the whole thing. Really. So the question probably relates to what Jane was probably alluding to, and actually, I think it's most relevant for the next slide, if you wouldn't mind. So the experts talked about the model quality as one of the things that they use to assure the overall quality of the AI solution. What did they mean? Did anyone elaborate on what does it mean? What does equality mean for that? Because oftentimes we see that the quality of the machine learning model performance doesn't necessarily translate to the business value that you're getting out of it. So you can be improving the quality greatly, but the business doesn't generate as much. Did anyone elaborate on that at all, or was it not really raised?
Oh, it's very difficult to understand what you're saying because the quality is not good. But as I understood, your question was, what is the quality for them? And is it also connected to the business issues, or is it only connected to the technical quality? That was the question?
Yes, yes, yeah, it was.
Okay, perfect. So several respondents actually talked about it. And for that, one of the quality measures then was the feedback of the clients. So, and before they start developing anything, they actually ask first the clients if they want it to be developed, or if they need it, if they can sell it, and then only then they start developing something. So of course, the quality and what the customers think about it afterwards is very important for some of the companies.
Great to hear that they care about it.
Answering your question.
Yes, it does, absolutely. Thank you.
So thank you very much. I see there is another comment, but I think that we can push that at the end because I think it's very much relevant for all the three different talks. So let us thank you again, Valentina. So we hope to see, in next editions, the follow-up of your article, your research, because I think that this is a very hot topic for this community. So thank you very much.
Thank you very much.
So let's move to the second presentation. Meanwhile, let me see if Marcus can. I see you online, but I don't know if you're able to talk and to interact for the third presentation. Can you, Natarajan, maybe offline check with him if everything is okay while we start with the second presentation? Because I see him connected, but I don't see his voice and is participating. I don't know if there is any issue. Okay, so if you can check, please. We'll move on with the second paper. And Valentina was pointing out that one of the main challenge was about software testing, and the second paper is about software testing. So please go ahead.
Thank you. I will share my screen. So I hope you see my slides and you can hear me properly. Okay, good. So my name is Chunyin Song. I'm a Wasp-funded PhD student in computer science at Lund University, Sweden. And I'm going to present our paper entitled Exploring Machine Learning Testing in Practice, Lessons Learned from an Interactive Rapid Review with Axis Communications. So machine learning is widely adopted to build different type of applications in various domains, including those safety critical areas such as autonomous driving. So at the same time, there is also a growing interest in the industry and academia to build the trust in those applications through testing. Also, there is clearly a need to establish effective ways to transfer the research outcomes to solve the industry needs according to their specific application context. So we believe that the industry and academia should learn together to produce rigorous and relevant knowledge in this field. So we conducted an interactive rapid review with Axis Communications here in Sweden. First of all, interactive rapid review is very different from the other type of review studies, such as systematic literature review. So interactive rapid review aims to provide a valid and rapid input to solve the practitioner's problem. And it doesn't have to be extensive in terms of the collected papers, but we have to actively involve the practitioners to continuously get the feedback from them. And according to the guideline, an interactive rapid review usually contains 5 steps. We start by preparing the review, then identifying the relevant review questions and develop the study protocol, followed by search and select the relevant papers, and then we extract and synthesize data based on the selected papers. Lastly, we need to disseminate the result to the practitioners and get the feedback of the results and also the overall study. So we, in our study, the first step, we try to prepare the review. So we form a review team which composed both the researchers and also the practitioners from Access Communication. We present our study and identify mutual interest and the information needs with respect to the general research topic, which is machine learning testing. So we, 4 researchers and 4 practitioners from Access Communication joined the initial meeting. We presented an overview of the recent research studies in machine learning testing using the taxonomy that we developed based on 3 secondary studies, which was considered the latest in the field. And also the practitioners, they provided their application context. In our case, they are trying to build a people content application using the surveillance cameras developed by Access Communication. So they tried to, based on the video sequence and the images recorded by their cameras, and then using the neural network to detect and count the people that appear in certain places. And the second step, we try to identify the review questions and try to set an agreement on a list of prioritized review questions. And we also agree on an initial review protocol on when, how, and who should be involved in each activities within this review study. So we proposed a list of 12 relevant questions based on understanding of their application context and using the machine learning testing taxonomies that we developed. And then we did an exercise by rating those questions based on our interest. And based on that rating, we selected the most 3 most important questions that we're going to study. So as in the current study, as the first iteration of this review study, we only focused on the first question among these 3 most important ones, which concerns more about how to test the data set. Because the data set is evolving, so there are many questions come after that. For example, how do we identify the mislabeled data in the data set? How do we assess and improve the data coverage in terms of the diversity? And how to assess the potential bias after the training and the test data set split? And lastly, also, how valid is the data set and its use? So there are many questions come after that, which we are going to search and select relevant papers based on. So we base our study on 3 secondary studies, which I assume many of us may recognize the names and the papers. So they are considered the latest in the field when we started this review study. And it contains originally 180 primary studies. We first selected 35 papers based on the first review question, how to test the data sets. So any papers that are not directly relevant to testing the data set are excluded. And then we, based on the practitioner's context, we further selected 5 best matches. So we want to include the papers that are based on image data sets and based on a mechanism of using the neural network as well. We read those selected papers and we try to extract the technological rules based on that. So a technological rule is a way to describe the research contributions by focusing on 3 basic elements: the effect, context, and the intervention that are proposed in the research papers. So we read those 5 papers and we extracted 9 technological rules using the pattern to achieve certain effect in certain context. We need to do some interventions. So in this way, we try to extract the technological rules from the papers. As an example, there was a paper proposed written by Ma and his co-authors. So the technological rule in this paper was to measure the quality of the test data for the deep learning systems using an adapted form of mutation testing. So the paper is about to propose a set of mutation testing operators to measure the quality of the test data. What we received from Axis Communication was that the paper and the approach they proposed in this paper was generally relevant to what they do, but they are working on a way much larger data set which contains millions of images in the full resolution, rather than the MINST and the CIFAR-10 data sets, which are 32 by 32 pixels used in this paper. So they want another pre-study to look further into this, how this approach and the technological rule can be used in their context. So the last step, as I already mentioned in the previous slide, was to disseminate the results to the practitioners and get the comments and the feedback from them regarding the results and the study. And they were positive to having such kind of collaboration, and they would like to have more study like this to look into some practical issues at their organization. So this was a study that we conducted together with industry practitioner Axis Communication, and we specifically looked at their specific need and their application context. And our case is a single case study, and as such is a proof of concept which can be extended with additional cases later. And also we plan to design a joint solution-oriented study on the topic of data testing as our future work. By that, I think I have concluded my presentation, and thank you all for listening.
Thank you very much. So let's see if there is any question from the audience. You can just take the microphone and speak. So we have no questions in the chat, so you're free to come and speak. So which is the most relevant? Okay, I don't know if Jane was ready to have a question. Do you,
go
Jane?
first if you want to, though, Henry.
Okay, please. No, go ahead, please.
So I'm kind of curious. I mean, I took a quick look at the paper. That you came up with some really interesting questions. I'm just kind of thinking about kind of looking ahead a little bit. Did they start to, when you were formulating the questions, did they start to also formulate answers for them, or are these questions that, are really have unknown answers?
So what we did in this study was we had a couple of initial meetings to explain our study, and we tried to understand their application context. So based on that, we proposed a list of 12 open questions must be addressed. And then we, together with the industry practitioners, try to rate all these questions based on the interest. And then we selected those most important ones to the literature based on that.
So I guess what my question says is, did they, they ranked the questions, and the questions look really interesting. I definitely want to, go and look at this again. But did they talk a little bit about how difficult it was going to be to answer those questions?
Well, what I can say is that they would like us to conduct a study to give them some input to solve those issues. And then we, based on their feedback, we collected a set of relevant papers, and we extracted the technological rules. And overall, what the feedback was concentrating on that. They thought these papers could be relevant, and they would like to experiment those approaches that we proposed. But the thing is, they are different in terms of the settings and the context. So they are working on something with much larger data sets, and there should be another pre-study to explore how valid or how feasible this approach could be used to solve their issues, to solve their problems. But they definitely want to have more inputs from the academia side to really help them, to support them to solve their issues in a practical setting.
Okay, great. Thank you.
Thank you. We have another couple of minutes if there is any other question.
Can I ask a question?
Yeah, please.
Hello. So I wonder what's the background of the developers in your study, because I'm thinking that maybe practitioners from different background may have different views. For example, if someone is from software testing, they might be more interested in the topics you raised, right? So what's that background? Are they all from AI, or are they anyone from the SC background?
Yes, that's a very good point. I think people with the testing background would definitely help us a lot in this kind of study because, yeah, as we have stated, we are studying the machine learning testing. So people who are relevant in this field would definitely help a lot.
Okay.
So maybe I can add to that question also, since I'm one of the co-authors.
Yes.
We actually had testers in the review team here, so that they were represented. So that was good.
The audio quality is not very high, Marcus. I mean, that's what it comes to me, at least.
Okay,
Please try
that's
again.
good. Since I am the next speaker, that should also.
Yeah, exactly. Yep.
But then I see this as a sound check. Then okay, I wanted to say that we had testers among the practitioners in the study as well, and not AI testers, standard software testers. Is the sound okay, or should I try something else?
Now it's better. Now it's better.
Is it good enough?
Yes.
Okay, good.
Okay, thank you. I think I will stop sharing then.
Yes. Thank you. Thank you very much again. And then we already have Marcus here ready to start.
Yeah, exactly. So you made me worried there about the sound. I wonder if I should unplug.
Now that you get it closer, now that you get the microphone,
I will keep it close to my mouth.
Not very comfortable, but the voice comes much stronger now. Yeah,
that's good. Yeah, just let me know if I'm not audible, then I will unplug and use the laptop internal mic, I guess. Okay. I'm ready. Do you want to introduce me, or should I go?
Oh, you can do. You can do. You know much more. You know much more about you than I do.
Probably, right? Yeah. So hello, Marcus Borg is my name. I'm happy to be here. I'm with RISE Research Institutes of Sweden, and as you see on the screen, I'm going to talk about quality assurance of generative dialogue models. So I'm going to talk about another area where deep learning excels, so natural language processing. And these are my co-authors here, reporting from this industry academia collaboration. So it's Piotr and I from RISE, and Alexander, the lead ML engineer at the company Nordaxon, and his colleague Isabella, and then Johan and Harald, two students from Lund University. So as we all know, at this conference, we need AI engineering. John mentioned that, of course, in the opening. We need that to reach mature AI solutions. And within RISE, when I argue that this is the case, I illustrate it with a staircase from fundamental via applied to operational AI. So AI that actually provides value in an organization. And this is where I see the Kane conference to help us take that last step. And this is an illustration of our general approach to AI engineering. AI systems are tricky. They are deployed to operate in a tricky context. That's why you need AI in the first place, right? So one challenge is the cake principle, as coined by Google. Changing anything changes everything. And that turns AI engineering and machine learning engineering to a very experimental endeavor. So we argue that we need to support this experimental work with integrated requirements engineering and solid V&V, and then a high level of pipeline automation in between. So time to show what we are working on here. So we're working on quality assurance of a conversational AI developed to help newcomers in Sweden practice the language. And the solution, Emily, later renamed into IDA, is an innovation project commissioned by the city of Helsingborg. And the conversation context is a fictive job interview, and the main goal is to support integration in Sweden, of course. And IDA will be presented as one of three main innovations during a Smart City Expo now in a few weeks. So we're looking forward to that. And the inauguration here will actually be a chat session with the Crown Princess of Sweden on June the 1st. So of course, quality is important to us. Two important terms before I continue. The first one is GDM, Generative Dialogue Models. Such models produce human-like replies to user prompts. And the second one is BlenderBot. It's a GDM trained by Facebook for open domain dialogues in English. And you can get it on Hugging Face. It's openly available there. And Emily is transfer learned from BlenderBot. So this means that the BlenderBot parameters have been tuned toward a set of job interview transcripts. And this is what happens behind the scenes. So a user speaks to a user interface in Swedish. And there is a third-party speech-to-text component followed by a rule-based toxic filter that rejects the worst types of horrible input that you typically get when you have those services online. Then we use Google Translate to go to English because that's where we have the language models. So the user prompt is sent to a GDM and a reply is generated and Google Translate back to Swedish. And then there is another third-party component that does text-to-speech to the local dialect here, and that is then played back to the user. And in this work, it's important to understand that what we focus on, the component under test, is really the GDM here, not the rest. And as an ML engineer, you experiment a lot to get several candidate GDMs, and it's not easy to say which one is the best and which one to deploy, and this is what we want to support here, the model selection. And the research questions then presented using the buttresses figure here. The first one is, what are the requirements on the GDM? Second one is, how can test cases be designed to verify them? And then third, how to automate them for the evolution of Emily. So we're looking at the life cycle perspective here. A few words about the method. So we did action research, defined as a disciplined process of inquiry conducted by and for those taking the action. And we followed the book by Professor Starren at Chalmers. And our choice of method was a watershed moment for the reviewers. Two reviewers were super positive, like, wow, this is a rare example of action research. And two reviewers rather assessed the paper as an experiment in a university lab. So I feel I need to say something about this to make sure we are on the same page here. So according to a recently published paper in IST, there are three closely related methods for collaborative industry-academia research, and they partly overlap. And Wåhlin and Runesson recommend method selection based on the primary goal. So design science methodology if the goal is to acquire knowledge through the design of artifacts. Tech transfer research methodology if the goal is to hand over research results to industry. And action research if the goal is to make a change in a socio-technical system. And also worth mentioning is that case study research normally means that the researchers are observers and try to avoid influencing the case under study. And in this project, we really wanted to make a change. We wanted to change how Nordaxon did quality assurance of GDMs. So we frame it as action research. And in action research, more than in the others, you become very tight with the company. So we spent many hours discussing company internals, such as how to secure funding for the next design sprints, how to replace developers who suddenly quit, and so on. And this is very different from any study you would do in a university lab. So I'll stop my rant here then and say that action research is done in cycles by an action team. We had 3 academic researchers here in the team, 3 AI developers, and the problem owner from the city of Helsingborg working on those research questions. And the cycle consists of 5 steps: diagnosing, action planning, action taking, evaluating, and learning. And during this cycle, we worked on requirements engineering, test design, and implementation. And it was done during the pandemic, as you might have guessed. So people worked from home. So we primarily collaborated through virtual stand-up meetings, sprint planning, shared Slack workspace, and a GitHub repo. Okay, the results then. 3 research questions. I'll take them in turn. So it's very hard to specify requirements on a GDM. You want to specify what it means to provide human-like answers, and that's like providing a recipe for passing a Turing test. So we did standard RE activities. We did elicitation with interviews and market analysis, specification work, analysis of requirements. We organized them, we prioritized them, we validated them, and we think that these can now be reused by others working on similar research challenges. And we selected 15 for test case design. And 3 examples here to give you an understanding. So the GDM shall provide replies with low n-gram repeatability. Repetition is a well-known problem for generative models. You might, for example, see I like pizza, pizza, pizza. For intelligence, we have provide coherent replies with respect to the ongoing dialogue. And for understanding, we have be robust against prompts with incorrect word order. To explain some test designs, I've used the same requirements. So for n-gram repeatability, you can simply count things. That's very simple. For coherence testing, we used a pre-trained BERT model to do next sentence prediction. I'll return to that. And for robustness, we used the following procedure. We provided the information, waited a few prompts, and then requested the same information. And then we repeated this with randomly swapped words and checked if the results got any worse. The test implementation we came up with was the following. We set up a dialogue between a default Blender bot and the GDM under test. And then sometimes we injected test cases then from a database, and we get the log and we analyze the log. And we did this for 3 subsequent Emily models and a Blender bot as a baseline. And this turns into some sort of benchmarking setup here. And we repeated this for 200 dialogues with 50 prompts each. And what we hoped for here was to reveal meaningful differences between these 3 models then of Emily. And did we do that? Yes, we did spot some differences here. So this is for n-gram repeatability. We designed a repetition metric that really captured that an early Emily GDM had a repetition issue. You can see here on the x-axis that for one of the histograms, the scale is totally different. Details are in the paper. For coherence, we used BERT for next sentence prediction. So in a nutshell, if BERT finds that at least one reply in a dialogue appears like a random sequence of words, rather than a reasonable continuation of the dialogue, it is flagged as faulty. And when we did this, again, we found differences between the GDMs and a trend toward fewer incoherent dialogues. So that's good. That's what we hope to find. However, note that coherence is such a subjective thing. To mitigate this threat, we validated the BERT scores on a sample of dialogue snippets and found an iterator agreement that supports that this test case design actually works for coherence testing of GDMs. And the final one here for robustness testing, we present a negative result because all the GDMs under test were terribly bad at remembering anything. So they failed even without adding any noise. I mean, they couldn't solve the basic case. So nothing to say about that. But what does this mean now then for others? How can this be useful for researchers and practitioners? Well, first of all, we think that the requirements we came up with here for Emily's GDM can be a good starting point for other researchers. And many of them are quite general, but it's very hard to pinpoint what you expect, as I said, a GDM to deliver. But we believe these are generalizable to also other types of GDMs, not only for the job interview session. Also interesting is that Yuan, one of the co-authors here, the second author, continued to work on this as a thesis worker at Nodaxon after we did this project. And he has now been working on operationalizing the concepts. So there is now this interactive Grafana dashboard to visualize some of the test results as you train new models. Yeah, this helps the machine learning engineers at Nordaxon with their model selection. So that's a totally different talk, I think. But our main message, at least, is that AI quality assurance, it needs to be tackled from both the RE and VMV sides, and then be nicely aligned to pipeline automation. That's super important. And this work then showed an example of how to do it for generative dialogue models. And that's pretty much it. So thanks for the attention. I hope the sound was okay.
Sounds was okay. So thank you very much,
That's good.
Marcus. Yeah, thank you. So let's see if there is any question from the audience. So while waiting, let me ask you, since you're guessing that the list of requirements may be reused in other similar system, I was wondering if you're planning to create a taxonomy of reusable requirements, or if that is just, let's say, a side effect of your research.
Yeah, well, taxonomy is a word that can be debated, I guess. But what we have here is an organization of different categories then of requirements. So I think that can already help understanding our set of requirements quite nicely. But yeah, it's a starting point and can certainly be extended.
Okay.
Yeah.
Okay, thank you. Any other comment or question? Okay, so let me call back also. I see there is one of the presenter that is missing from the screen, at least. Yes, perfect. So just summarizing, I saw essentially 3 empirical studies. So this let me think, as we know that our community is still very young and we want to discover, what is happening around us. First paper was about a study on quality, second one in machine learning testing, and third one that we just heard about quality assurance for this particular kind of system. I will start because there was one question before in the chat that I didn't forget about, that was about tool support. And I would like to ask the 3 of you if you did any specific check or experience related to tooling on your own research area. And we may start from Valentina, for example, if you want.
Yeah, we can start with me. And yeah, I actually have something to contribute to this question. We had one participant who mentioned that they wanted to automate as much as possible and make the test coverage as high as possible. So they developed themselves everything from scratch because there was no tool that was that could provide this what they wanted to do. So it's everything. So they built a monitoring tool that was comparing the models against each other after every change, and then also like saving which kind of data was used for training a model, with which kernel, with everything, and they built it themselves, which might be the answer to the question that they didn't find the existing tool for this. So and they said that it's a small startup, so they have a step with the little contributions, and takes, of course, a lot of time. But they are going to develop their own monitoring tool.
Okay, thank you. Kunjing?
Yes, since in our study we were exploring the machine learning testing based on the existing literature, so there was not too much about this tooling part we were looking into, but I assume that later if we are exploring the solution in the data testing area, there is certainly such a need to look at different tools that we can adopt to improve the efficiency or the effectiveness of the testing. I think you are muted.
Yeah. So what about you, Marcus?
Tool support, yes. Yeah, we worked also on supporting, I mean, tooling, test automation is I guess tool also. So I think the original question was also, did they complain about the lack of tools, right? These developers. So the Nordaxon company is a typical AI company, I would say. They don't have the software engineering background. That's important to realize. They are mathematicians, statisticians, data scientists, and yeah, they have different. They have studied some computer science, but they don't have the engineering background, so they don't really know what they're missing in terms of tools. I think to a large extent, but they are monitoring the open source space, for example, when it comes to those conversational agents that they are working on. There is still support available. For example, there is an open framework called RASA for dialogue management, and they use that. That supports the quality of the dialogues, but it's not a typical software engineering tool, I would say. But yeah.
Yeah, in fact, I totally agree with you that I believe that one of the most interesting and challenging aspect in this community is that we are essentially bringing together at least two different community with different histories and different experience and way to work. Also, we had an experience with a company in creating or implementing a sort of agile process. And the very interesting part was that they were used, the two teams, the ML team and the software engineering team, to two different processes, two different tools. And this was very kind of interesting and challenging. And I think that this is one of the messages that is coming from at least some of you. I would like also to see if any three of you has a comment or a question for any other author here in this, just to see if there is a connection. I know that Marcus and Kunjing, you are you have already connected because two papers are the Marcus is there, but I would like also to check if there is any link that you see from the three papers that have been presented in this session. So, for example, Valentina, let me just start with you because, in a sense, your paper was the most, overview or most, kind of overall. And my point was, if what has been presented by the other two colleagues, you see fitting in some way with the results that you get with your study, for example. I was mentioning that testing was one of the challenges, and then we had a paper on testing, but let me leave you some space to see if there is any other connection that you see. And again, the same applies to you, Marcus, and to you, Kunjing.
So from my point of view, the paper of Marcus, he also started to talk a bit about the data pipeline, the pipeline automation, and this might be like what I'm going to do next. And I think it's one of the main things to assure the quality right now, just to automate as much as possible. And you were starting working on that, right? So
yeah, sure. That's the whole point. We want to deploy our automated test cases in the pipeline, and that's what we're working on now and have been working on the last months.
Mm-hmm. Yeah, but that would be also very interesting. What tests exactly you want to apply, what issues you want to prevent, and just in details, like which bugs appear and which you want to focus, because you can't implement all the tests, right? You want to focus first on this test and then next on the other tests. So based on the priority, and it would be also interesting to see what do you think about it. What is the priority right now?
Was that a question to me?
That's a rhetorical question for all
yes,
of us.
Exactly. Good.
Any comment or question from the audience at this point? Because I would expect that this topic, indeed, quality assurance has been always a huge topic in any community and in any technology that we have been facing and changing over the time. So I think it will grow very much, and I also believe that many people here connected will be interested, to this kind of topic. I don't know if Ipek has any question.
Yeah, I just posted it on the chat as well, but this is for all authors. This is consistent with some of the studies that we've been making and some of our interactions with the organizations we work with. There's definitely quality assurance and testing challenges, but there's, I think, a difference between new testing challenges that AI elements bring in, as well as underutilization of existing testing techniques for these systems, even with or without AI components. I don't know whether, I know all these studies were focused on AI elements and what is new, what is different, but did you come across any of that perception as well? Using some of the existing techniques might also help to start with, in addition to new techniques.
So I can start because it's very obvious in my case. As I said, the AI developers here at this company, they didn't have the software engineering background, so whatever I could present to them was quite new. And such a simple thing as having a proper regression testing framework with quite simple test cases, but just show that, run this every time you train a model, run this and see what happens. I mean, that's such an easy solution, but it brings substantial value. So that's an easy answer. But there are other things as well, of course.
Yeah, that's consistent with what we've seen. They overlook some of the even existing techniques with or without software engineering experience. I think that's also an opportunity to improve. Yeah.
I also noticed that. Please go ahead.
Yeah, I could also add to it that in my case, so many companies use, for instance, Python. And for them, even the basic code standards, like how to write, how to name variables, how to write the code, how to make it more readable, like for some of them was an issue. Because if you don't have this strong software engineering background, or not even strong, like the introduction to software engineering, sometimes you might miss it. And of course, people with the statistical or math background need an additional training, let's say, in some basic stuff.
Thank you.
And I guess in my case, that all the practitioners involved has some kind of like software engineering background. Some of them even are experts in this field. So I can hardly assess that for those people come outside this area. And we are more in this study to provide input to them rather than to look into their industrial practices or look into any of their environment. So I cannot say too much about that in this case.
Yeah, fair. Well, thank you all.
Thank you.
Thank you. There was also another question that I noticed only now from Sridhar in the chat. I don't know if you want to make the question directly, boys. Otherwise, we can read it. So it's about AI systems may have other non-software aspects, and how do you see quality assurance in this context? Did you observe any insights on handling these during your work? So here is not specified what non-software means, but they mean a lot indeed. I mean, if you look at IoT or cyber physical systems, I guess this is in that line. I mean, if the Sridhar is here, maybe we can get more information on the question, but let us, have in this couple of minutes, if you have experience in your research on components which are not only software, and what may be, the role when you apply quality assurance or testing.
So I can just start. It's an easy answer again for me. I mean, microphone quality, for example, if you do voice recognition, that's a non-software issue, but that matters a lot. And background noise in the room where you actually run it. I mean, there are many aspects here.
Yeah.
I was looking to, in our study, looking into different systematic literature review studies. So there were different perspectives about software aspects or non-software aspects mentioned there. And how do we handle this? It actually reminds me back to what